You probably thought we were just doing maths, but then we started to talk about laws. It turns out we need some rules in the world of maths when we are dealing with countless numbers, all of different sizes and types. Otherwise, it would be chaos, just like a real world without rules. Thus, we started off by learning the laws of addition and covered two of them. The last we discussed was Commutative Law, which said that the order in which we add two real numbers doesn't matter because the sum is the same. What if we have more than two numbers? The Associative Law will help us out here. Let's take an example with 4, 5 and 1. You could find their sum either by adding up 4 and 5 first, which is then added to 1, or you could add 5 and 1 first and then add their sum to 4. In either case, the answer will be the same. In general, for all real numbers a, b and c, we get the same answer when we add a to the sum of b and c, as when we add c to the sum of a and b. Pretty straightforward, right? As easy as the Additive Identity Law, I'm sure. This law says if you pick any real number and add an identity element to it, then it will give you the same real number back. What's that identity element? A 0, of course. Let's try it with 3. What can we add to it that will give us 3 again? 0 is the only possible option. But guess what? This isn't how the law actually looks like. There is a lot to it. Life isn't that simple, right? And I want you to learn how to decode such symbolic forms. So, we are going to crack it piece by piece. By recalling previous lessons, we can tell without a doubt that this is a binary operation, right? Therefore, the conditions of binary operation apply here too. That is, both the operands a and 0 belongs to the same set of real numbers. Next is this symbol. We already know that it means for all, while this new symbol means there exists. By gathering this data, we can easily read the symbolic statement. For all real numbers a, there exists a real number 0, such that if you add it in a, the result is the same real number a again. And it doesn't matter in which order you add them, you will still get a every time. Bingo! I hope you can read the others yourself from now on. Next and final for this lesson is the additive inverse law. This time we want to do the opposite. To which number can we add a real number such that we get 0? Let's use 3 as an example again, because 3 is a charm, right? If we want to get 0, we just add 3 to minus 3. That makes 3 and minus 3 the additive inverse of each other. And that works for any real number. If we have a, then we will definitely have its additive inverse minus a in the same set. And if you add them together, you get 0, regardless of which order you add the two numbers. A little side note to remember, if you ever see something like this, you should read it as negative of negative a and not minus minus a. That's it for this lesson and the addition laws. We will move on to multiplication in the next video. They are pretty similar, as you will find out, which is good news for us. Not too many rules to learn and more maths to enjoy.